All right, y'all, welcome to this video where I'm going to more explicitly teach you how to answer these task questions where we ask you to explain your reasoning or build a model and use it. These are a big part of really rigorous math, like showing that you not only you can arrive at the answer, but you can describe the mechanics of what's going on. They're also a big part of the MCAP, and so we want to make sure that we can answer these style questions. And so we're really going to zoom in and kind of train ourselves to answer these questions at a high level. On the MCAP, they are scored out of 4 points. And to get the full 4 points, you really need to not only arrive at the correct answer, but really demonstrate that you can describe how to do it. So I'll go a little bit slow here. We have example one here. Marvin starts a business selling custom designed hoodies. To start the business, he has to purchase startup materials, and thus he starts $800 in debt. He profits $20 per hoodie that he sells. Okay, and so we have part A that says create a model that represents this relationship between the amount of hoodies Marvin sells and his profit. I gave you a box for each part, and I also gave you Scratch. And that's where you could write out some of the math you want to do. And that's imagine that's like the box on the Desmos where you can show your work. And so generally something to remember from when we answer these questions is we can't grade anything that's on your paper. I know you're doing these on paper as we practice, but if you want someone to see that thinking, it needs to end up either in the Scratch box or where you're answering the question. So, all right, let's do this. Create a model that represents the relationship between the amount of hoodies. All right, so what do we got going on here? He starts a business $800 in debt, and he profits $20 per hoodie that he sells. I'm gonna do you might dive right into just writing down y equals mx plus b because that's the only type of function that we've learned so far, linear functions. But a level 4 answer here would explain why this is a linear function, because eventually we'll learn about some other types of functions. Well, this is a linear function because um, it is multiplying at a constant rate. All right, it's adding at a constant rate, not multiplying. It's adding at a constant rate. Every hoodie he sells, he gets the same amount. It's a constant rate. So in my answer, I want to describe if I'm using y equals mx plus b, I want to describe. So I'm going to say, I'm going to type my answer here. So I'll be doing some writing and typing here. I'm going to say I modeled. Actually, before we type, let's just actually make the model. That's probably what I'd do if I was approaching this question. So y equals mx plus b. He begins $800 in debt. So I know my b is actually going to be a negative 800. All right, hopefully that makes sense. He has debt. This often happens when we um, start a business. We start in debt because we have to buy things to be able to start the business. He gets $20 per hoodie. So that's the rate of change. I'm going to fill that in for M. And since it's per hoodie, I'll do an H. And this all equals his profit. So I've created the equation. P equals 20H minus 800. This is my model that I have here. So let's first type our model over here. I created the model. P equals, I'm going to say equation. Create the equation P equals 20H minus 800 to represent a relationship. So first, I just kind of answer the question in a complete sentence, right? Now, I kind of want to describe my thinking here, but I also want to define my variables. So if I'm going to include this P here, I need to say what P means. So I might say somewhere like P equals profit and H equals, and I don't want to just say hoodies. I want to say hoodies sold, right? It's how many hoodies he sells. So this model describes the relationship between how many hoodies he sells and what his profit will be. If he sells 0 hoodies, he'll be $800 in debt still. If he sells 100 hoodies, then he'll have profit, all right? So, all right, I want to explain how I arrived at this. All right, again, the more you can explain, the better. How did I know to use y equals mx plus b? We talked about this because It's adding at a constant rate. Linear equations have two parts, a beginning and a constant rate or a slope. So I'll say I used a linear equation to model this relationship because the amount, because each hoodie, he profits the same amount so that his profit adds at a constant rate. All right. When you show off to the people that are grading these a little with words like constant rate, you show them you really understand what's happening. If you got $20 of profit for some hoodies and $30 for a profit for other hoodies, that would not be a linear function, and we could not use this y equals mx plus b. So you have to show, oh, I'm using y equals mx plus b here. Why? Well, because it's changing at a constant rate. And so, most of you would be able to get this model, but being able to explain it like this really helps you get full points on the question. All right, let me put some space here. All right, now let's look at part B. How many hoodies does Marvin need to sell to break even? Again, sometimes you need to have some real world vocabulary here. If you're going to start a business, calculating your break even point is really important. Break even point is when your profit is zero. You don't need to draw this part, so I'm going to draw it over here. So just really, this is going to be me showing you something, right? Imagine we have this graph where we have your profit and your amount of hoodies sold. I'm going into more detail than I need to here, but that's okay. Well, where do you begin? Hopefully you know. Where does he begin? He begins at negative 800. And then it's going up and up and up, all right? So when he's down here, he's in the negatives, he's in debt. When he's up here, he's in the positives, he has profit. But there's this point right here where he has neither debt or profit. That's your break-even point. And so what is that point? How much profit does he have there? He has $0. So he has $0 in profit. So how can I figure out how many hoodies he needs to sell to have $0 in profit? Well, I can plug in. Because I know profit is 0, I no longer need a variable to represent an unknown number. So I'm going to plug in or substitute a 0 into P, and then I'm going to solve the equation. So let's say 0 equals 20H minus 800. And now I'm just solving a two-step equation. Again, it's very important that you know how to solve these equations. I add 800 to both sides. These cancel. I get 800 equals 20H. Divide each side by 20. Now, I know I can do this math in my head. It's H equals 40. So it's 40 hoodies. But you do get a tool on every task, the Desmos calculator. So if you want to try using the Desmos calculator, this is the calculator you get on the MCAT. Eventually, this is the calculator you get on all our assessments. You can type in 800 divided by 20, and it's 40. All right. You could even do things like, you can even type the equation here. I don't know if it'll solve it. I don't think it will. No, it doesn't. So, but you can do basic math there. We'll go over how to use Desmos in another video. Okay, so now I know it's 40 hoodies. I've shown in the scratch box how I arrived at the answer. And if this was something you had to type, if this was an answer you had to type, you wouldn't just leave it right here on your paper. You would actually show this in the scratch box on Desmos if you want it. So this work needs, whatever's in this scratch box needs to also be on the scratch box on the computer. So, all right, we're ready to answer the question now. Again, I'm going to start by just answering the question in the complete sentence. In order to break even, Marvin, and you should be writing this on your paper, obviously, need to sell 40 hoodies. I arrived at this answer by plugging 0 into P in my model. All right, that's what we did, right? We plugged 0 into P in the model. Then I solved the equation for H, and I got 40. Right, that's it. We don't need to type a novel. Sometimes you need to type longer, but that's pretty much it. That would get you a full score, right? You would have to describe how you solved the equation if you didn't show it in the box, right? So imagine you didn't show it in the box. You could say, I made the equation, or like, then I would just show it down here. 0 equals 20h minus 800. Added 800 to both sides. 800 equals 20h. I divided each side by 20. H equals 40. All right, so this or this, you don't necessarily need to do both, though it doesn't hurt. Okay. All right, so that's kind of an example on how to get a 4 out of 4 on a task, right? You need to not only arrive at the correct answer, but explain the thought process behind that. So hopefully, again, we're slowly going to get good at this over time. And I think you'll grow to like these problems because it's really where you get to show off your thinking, prove that you're a good thinker. All right. And then you're creative. Okay, let me get this. All right, now I want you to try the you-do. We, of course, will go over it. Let's see, I need to clear this out. But first, I want you to pause, and I want you to try this completely on your own. So take your time. Again, this is where the learning happens. If you just wait for me, I'm sure you'll get your full points on these notes probably. But on our next assessment, when you don't know how to do tasks, which our assessments are worth way more points, you won't know what you're doing, and your grade will suffer. So go ahead and pause and solve. Okay, hopefully you're unpausing and you already attempted it on your own. What I don't want you to do here is erase anything that you've done and change it to be more like mine. These are open-ended, so your answer may be a little bit different than mine, but it may also be correct or close to correct. So let's read this. Deja started a new running routine and has already run 25 miles. She plans to run 5 miles per week. She wants to create an equation that models the relationship between the amount of weeks passed W and her number of miles run M. 4 of her friends offered the following equations. Corian, M equals 25 plus 5W. Deja made her own equation, I guess. M equals 25 times 5W. Jasmine, M equals 25 times 5 to the Wth power. And Maribel, M equals 5W. It says, which friend, if any, created an equation? Explain why the equation is correct. Well, hopefully you got this. The correct equation is Corian. And the reason we know that, again, and hopefully use the words constant rate in your equation, is that she runs 5 miles per week. She runs the same amount each week. Remember, linear equations have a constant rate of change. So it's going up constantly, 5 every week, 5 every week. And of course, she has a beginning where she has already run 25 miles. So we know we can use the equation y equals mx plus b. And I can fill these in, right? She began at positive 25 miles. She's going up 5 per week, and this all equals how much she's run. Well, you might be saying this looks different than Corian's answer. Well, 25 plus 5W and 5W plus 25 are the same thing. The order doesn't matter for addition, right? 4 plus 5 is 9. 5 plus 4 is 9. The order does not matter with addition. So now that I know Corian is correct, I want to make sure I can describe this in my answer. So let's say, all right, Corian made the correct equation. All right, so I just start by answering the question. I can say, I know that his equation is correct because his model is a linear equation, and so is the relationship between Deja's miles run and weeks. Right, it's a linear. Now, how do I know it's linear? It is linear because she runs the same amount every week, and thus it demonstrates a constant rate of change. Okay. Again, your answer might sound a little bit different, but as long as you A, got the correct equation, B, explained it, and hopefully used words like constant rate of change, then your answer should be correct, right? And so this answer is long enough, especially to match with this. They can see how I created my equation over here, and they can see my explanation right here. So that should be 100% correct. All right, Deja's goal is to run 365 miles in a year. Will she achieve this goal with her current running routine? If not, what adjustments does she need to make to reach her goal? Okay, maybe I should write this on the board when y'all are working on this. There are 52 weeks in a year, so you need to know that information here. So if there are 52 weeks in a year, I need to figure out how many weeks she will have run in a year. And so to do that, I need to plug 52 into W, right? Because it's been 52 weeks. That needs to go into W. So that's a little tricky. It gave you the time in years. You had to convert it to weeks. But really, I can rewrite the equation. It's M equals 5 times 52 plus 25. Again, you're allowed to use the Desmos calculator. So we could plug this right in to Desmos if I wanted to. 5 times 52 plus 25 is 285, right? 5 times 52 is 285. So M equals 285. So in a year, she'll have run 285 miles. So does she reach her goal of 365 miles? No, right? No, she does not. So let's describe our answer. Deja will not reach her goal of running 365 miles in a year. Right? I start out by answering the question in a complete sentence. Now I'm going to explain my logic a little bit. She will run 285 miles in 1 year. I arrived at this answer by plugging in 52 to W in my equation because there are 52 weeks in a year. Then I solved for M and got 285. All right. So now I've answered the question and I explained how I got it. Boom. This is a perfect answer. Hopefully, you'll get better and better at these tasks. Please do not shy away from reading or writing in the math class. If we want to be able to use math in the real world, which is our goal, then we have to be able to read about real world situations and apply that math and then explain our math. There are some practice tasks for you to try online. If you need more help with tasks, please find your teacher.